Hello, welcome to the FRQ of the day. So today we are going to start the 2008 Form B FRQs, and so we're going to do number 1 today. So let's see if we can figure this one out. This one said a certain state's education commissioner released a new report for all the public schools in that state. This report card provides a new tool for comparing schools across the state. One of the key measures that can be computed from the report card is the student-to-teacher ratio, which is the number of students enrolled in a given school divided by the number of teachers at that school. The data below give the student-teacher ratio at 10 schools with the highest proportion of students meeting the state reading requirements in the 3rd grade, and the 10 schools with the lowest proportion of students meeting the state reading requirements in the 3rd grade. So there are the ratios for the 10 with the highest proportions, the student-teacher ratio, and there's the student-teacher ratios for the 10 schools with the lowest proportion of students meeting the reading standards. So part A, display a dot plot for each group to compare the distribution of student-to-teacher ratios in the top 10 schools with the distribution in the bottom 10 schools. Comment on the similarities and differences between the two distributions. And part B, any statistical test that is used to determine whether the mean student-to-teacher ratio is the same for the top 10 schools as it is for the bottom 10 schools would be inappropriate. Explain why in a few sentences. Okay, if you want to pause the video and give that a shot, that would be great. Okay, so this is asking us to make 2 dot plots, and it says to comment on similarities and differences. Well, here are the 2 dot plots, so you just make a little number line and put dots for those numbers and dots for those numbers, and make sure to properly label it and scale it. And so there's my dot plots. Okay, there's for the 10 highest performing and the lowest performing. Now, if we were asked just straight up to compare them, to describe the distributions and compare them, we would cuss using comparative phrases. We would say the center of this, it's about, the center of the highest performing is about 16, which is very similar to the lowest performing, which is that. We talk about unusual value. Are there unusual value outliers? There's not. In regards to shape, it's hard to tell much for shape here. There's really not any strong skewness. They're relatively symmetrical. And then their spread, you could easily compute the ranges and compare those. But this one specifically asked to compare the similarities and differences. And so you really just had to say something like this would be fine. Is you would notice the similarities is their centers are quite similar of these two distributions. They're both centered around 16. And so you'd say the distribution of student-teacher ratios. Make sure and say the context. The distribution of student-teacher ratios for the 10 highest performing schools has a similar center. All right, so that would be something they have like around 16 to the 10 lowest performing schools. So that would be a similarity. A difference would be is that there's more variability in the higher performing schools. More variability. All right, certainly with a bigger range. And so you would say the 10 highest performing schools have more variability than the 10 lower scoring schools, with the range of the higher being 15 and the range of the lower being 8. Of course, the range, you take the biggest number minus the smallest, and for the highest it would be 22 minus 7, and for the lowest it would be 20 minus 12. And so there you go. So that's that one. And then it asks, or then it says, okay, any statistical test that is used to determine whether the mean student-teacher ratio is the same for the top 10 and for the bottom 10 would be inappropriate. Why is that? Well, there's no sample taken. There's no random sampling. This is the entire population. There's no sense in doing a test about it, making hypotheses and all that, because we can find the means. We can find the mu's, okay? So you just had to basically say no, because it's not appropriate because there was no random sampling, or because these are the entire populations. There's no sampling going on. So there'd be no point in doing a test. And so you could say something like this. You could say the 10 schools in each group are not random samples from larger populations. In fact, the 10 in each group are the populations of interest. In other words, these are 2 censuses that occurred here, censuses of size 10. So an inference procedure like a test is not appropriate. So there you go. Every once in a while, they'll ask that question. Thanks for stopping by. Thanks for watching. Please send me any questions you have, and I hope you're doing well. And we'll chat with you again tomorrow.